Hi guys, I don't know how long this video will be. It'll probably be a short one. I wanted to kind of bring you up to date on where I'm at, and I haven't done a whole lot more to the radio itself at this point. I've been working on the supply. This is where I'm at. I'm just mocking stuff up. I need more connectors for to tie in for one extra B plus along, and still have my B minus as well, and also for the A circuit to be hooked up. I kind of figured that I'll put a fuse here instead of using a CL90. I know there was some questions on that. I was planning on doing it, but I'm going to use this little guy, or big guy. It's a same thing basically, except the CL90 has a cold resist, or a hot resistance, excuse me, have I believe around like 3 ohms or something of that nature. This has a hot resistance of 19 ohms, which what that'll give me is roughly the ability to be able to plug into the main line and not have to worry about trying to reduce it anymore. This should reduce it down enough that for where this thing was meant to be working at for working voltage. Cold, it's running around 230 volts, so it should create a pretty decent soft start, and I'll mount it somewhere by the fuse. I'll get to this in a minute here real quick. There was a question about how I got the chassis so shiny, and I'll show you. I cheat. I'm lazy. I'll admit it. Right there. That's how I did it. That's just a portable sander and polisher. It's got this nice little pad on it. Darn thing's older than the hills. It used to belong to my dad. He had it for, I think he bought it new many years ago. And you know, what I used on it was Mother's mag aluminum polish. Now, I like this stuff. Don't get me wrong, I don't have a problem with, and I got Simmerchrome. I don't have a problem with Simmerchrome. Simmerchrome I really like on like your bake lights and some really hard to polish aluminum and other metals if it's being real stubborn. This has got a little more grit in it than this does, and especially on the cans, the aluminum cans that was on this on the Atwater Kent. Since they're coated already, they've got a some sort of clear coat or something on them. This didn't seem to want to bother it. Just polished it up, cleaned it up, and polished it up nicely. So, besides that, any automotive parts store, it's pretty reasonable. I don't even remember how much this cost for sure. And it's made in the USA. Right there. Made in USA. So anyway, back to this guy. What this is how we get rid of hum, or hopefully we get rid of hum. It's not exactly like a situation where, wow, it's gone, never have to worry about it again. It's more like we get it down to a level that it's, you know, hopefully down below the static level of the radio. And basically how you hook that up is, and I'll show you several different means the manufacturers have used over years, and this is one way. You put the resistor across. This is your AC filament going, this will be going actually to the power amplifier tube, but it can go to any of the tubes. You put it across there, then the center wiper comes off and just goes to ground, B minus, and you just adjust it to get the lowest amount of hum. And basically what it's doing is it's pulling establishing more stable voltage here by taking part of it to ground on each side of the line. Now, generally it'll come out where it'll work out pretty much almost right dead center, where the two are equal. And the whole idea of that is AC is always fluctuating, going up and down. You know, it's a sine wave. What this does is try to stabilize it a little more by pulling some of it down and creating a voltage drop on each side here. It's kind of like a little voltage divider, and then that's what feeds the filaments. It's a really simple little trick, and and that's really what it is. It's a trick, but it works. It's what they've done for years. I got a Majestic. It had several different voltages. Now this 5 volts, it's on the power supply. There's a resistor going across. It's tapped off. But the one hum adjustment here is going to the first audio, and that actually is adjustable, and it's a 20 ohm across the 1.5 volt. It goes up to the filament. And then the other two that's going to, well, this goes to the detector and these go to the RFs. They're straight tapped off, and they all just come back and go through some more resistance, but back to B minus, or ground basically. And that's how the Majestic did it. As far as here's Atwater Kent model 66. Here they're all the main tubes, the RF tubes up here through the detector and the first audio are all tied together on the same filament, and it's kind of hard to see it, but it's a 10 ohm resistor going across there that's tapped off going to ground, right? Probably right at center. And then up here on the output they did another 10 ohm and tapped it off right to ground. So that's all there is to the hum reduction circuitry. Like I say, it's just a cute little trick, but basically all you're doing is you're establishing a voltage on this resistor that stays a little more stable than the AC. It doesn't want to shift as quickly, so that allows the filaments to stay more stable. They don't give it as much chance to cool off. Now my question was simply, and these guys, you know, pretty much Raytheon said that it will work on this 112 tube. Now this 112 is a triode tube that's used for audio amplifiers and detectors, but it's an AC, or AC, DC only tube. Now the 171 is AC or DC. Now there's some minor differences inside the tube. One thing that they do is on like the 171 or any tube that's designed to also handle AC, is they make the filaments heavier and shorter. They draw more current, but they get hotter, so they don't cool off during the period when the AC is going to zero, before it starts building back up, like going to the negative and then back around. Where your DC has thinner and longer filaments, less resistance in them, and or more resistance in them, and they don't get as hot. But they're saying that this will work just fine on that by just simply using somewhere closer like a 400 ohm. So that's what I've got in here. We'll give it a try. If not, we'll pull off the main rectifier and build up a circuit similar to this to pull our A voltage off of. Now the other thing I wanted to talk about a little bit is yeah, I got a little time here. TRF radios can be a pain in the rear sometimes, but they're a very simple radio. Basically all you've got is, now like in this Majestic and as well as this Atwater Kent, I think in the Atwater Kent. It's got 3 RFs. There's 3 RF sections, and then you go to the detector here. All's in the RF. These are tuned RF. You got a tank circuit here, a coil, capacitor. Just the same thing as you have with like your antenna coil and your tuning capacitor that's on your regular, All American 5, any other radio. Except in this case, we got one here, we got one here, and we got one here, and there's one here. There'll be 4 of them with 3 stages of amplification, as like in this radio here. And now the thing about these are real broadband. They're what they call tightly coupled, which just means that the transformers here, the coils are real close together. That's all tightly coupled means. But what that does is give, unlike an IF, which might come up, up like this and back down, pretty narrow bandwidth. These are more flatter. I mean, they round off a little more, and it's a lot wider. It allows them to operate better and tune in, and any variances in the tubes and the coils and everything, to be able to tune in a radio station. Now these radios, like this Majestic and this Atwater Kent and the other Atwater Kent I have, that's a 40, and they're new enough that the gangs are connected together. The capacitors are connected together either by one shaft or by, like you see on the Atwater Kent that I've got here, the pulleys and ribbons. In the old days, compared to these radios anyway, you go back a little further in time, a couple years or so, you would find that these were individually turned. Each capacitor you had to turn individually, which made it rather interesting trying to tune it in. So it didn't take them long to figure out that maybe we ought to kind of gang them up a little bit. From that point, it just goes to the detector, and then your first AF, and then your push-pull output, and out to the speaker. This is what is known as a grid leak detector. Basically, it operates by building up a certain amount of voltage on the capacitor. As the signal goes through, it'll charge this capacitor. Eventually the capacitor gets fully charged. This keeps the grid biased to a certain point. The actual detection is done between the grid and the cathode, and the tube actually operates as 2 tubes in one, even though it's just a simple triode. The plate is more positive than what the grid will be. The grid will be a little bit more positive at times than the cathode. By doing that, we can block signal at certain points on the wave coming through, and other times allow it through. That allows our detection, so it acts like a diode. When the signal does get through, that's when the grid becomes negative and everything flows. Then it flows out and it is amplified through, and you can quote the interstage coupling transformer to the next tube. Some of the big problems with these got to be very well screened, otherwise they'll regenerate, meaning that the signal from one tube that's coming out of here will just go through and enter the other glass envelope, the other tube, and we'll end up with oscillation going on, squealing noises. I mean, they can get really bad about it. And then the other dilemmas is that since they're so broadband throughout the entire circuitry, then if you have 2 radio stations that are fairly close together on the dial, you get both radio stations going through. So they're not too selective. But that's about it. I'll continue working on this. After I get this pretty well where I want it, then I'll take it apart and paint it up. One other thing, Atwater Kent like using a real dark brown on their canisters that holds their transformers, and of course in this case the A battery and stuff. That is, for me, where I'm at, virtually impossible to even come close to that brown. I mean, if I could at least came close, it'd been alright, but there was no way. So since that brown is so dark and it's almost black, in fact the only way you can tell there's a difference is if you actually hold it to black. I've opted just to go with black on the stuff, because the one container, the one can that's on there, the big one that held the batteries in it, had some issues where the paint lost and some rust, and I wanted to make sure that it's well protected. I don't think under normal circumstances it'll be noticeable, because the brown is appears to me be like one shade from being black, but I just couldn't find it around my area, so that's where we're at on it. So hopefully on the next excuse me, the next video I'll be a lot further along. Hopefully I'll have the tube, so then I can show you how I'm mocking up the resistors and how I figure out what the resistors should be on here. Until I get the tube, I'm not absolutely sure how much drop is across it and what, you know, with it in, what kind of voltage I'm going to have. And until then I can't tell for sure what I need to do. As far as, I think that's about it. Anyway, by the way, this is my normal, what my bench looks like. I kind of lie to you guys, you know, I'm dishonest with you. Normally when I'm making videos, before I do it, I clean the bench off so it looks presentable. It's usually in fact, this is actually not too bad. It's usually in a lot more chaos. Oh, by the way, for you TV guys out there, I have a bunch of stuff I ran across a long time ago and picked up for nothing. A lot of these amp fuses, yeah, these two are W2000-1s. Also, anybody, there's two of these guys. These go on the degaussing circuits and TVs. These are like CL90s, except much bigger and healthier. This one here is a 200-10 200-10 fuse. Another chemical fuse. It replaces RCA 104295. A model, another amp fuse model 500-1. I've got several of those. Let's see, that says 200-10 and 200-10. Anyway, anybody needs any of these, you know, PM me, private message me, and I'll send them to you. No cost. I won't ever use them, most likely. I do TVs, but they're hard to find in my area unless I find them locally. I'm not going to have one shipped to me. So, and for the most part, these are probably a lot newer than any type of TV I'd ever mess with anyway. So, but if there's any guys out there that, you know, this piques your interest, hey, you know, drop me a line, you know, a PM, and I'll kind of, you know, I'll send you some pictures or whatever, and you can look at them closer. So, anyway, this has been long enough. I thought it was going to be a short video. Nothing's ever short with me. I talk too much. So, until next time, thanks for your comments and your support and kind words. You guys do have quite kind words. So, and Anyway, I'll see you on the next video. Bye.